so much, Arian. Thank you, EBCNA, so much for this opportunity. So yeah, to begin my journey, when I first entered the PhD program here at the Mayo Graduate School of Biomedical Sciences in 2011, I wanted to actually focus on cancer biology. And so my thesis project was looking into the development, what is called this new onset of diabetes, or what is clinically characterized as a type 3C diabetes in pancreatic cancer patients. And this is distinct from diabetes that we are all familiar with, type 2 and type 1 and type 2. And it's been shown that a subset of these pancreatic cancer patients will actually develop this new onset diabetes, which precedes the diagnosis of pancreatic cancer. And so we showed that the development of new onset of diabetes is unique in that it develops by the release of tumor-secreted factors. And we identified a particular factor of interest and found that it was enriched in extracellular vesicles and released by the pancreatic cancer. So my journey into the EV field actually started back in 2011. And then after I graduated, I joined my postdoc mentor's lab at the Mayo Clinic, who happened to be a collaborator of my PhD mentor. And although my training at that point was all in cancer biology and exocrine pancreas biology, I wanted to learn more about endocrine biology and diabetes pathogenesis, so I could kind of market myself as a pancreas expert. So during my postdoc, I gained all the necessary skills and tools and knowledge in islet and beta cell biology and diabetes pathology. And then since my goal is to ultimately go into academia and to have my own independent line of investigation, towards the end of my postdoc, my mentor and I started to think how I could branch off to do this. And it all kind of came together quite perfectly as I ended up merging what I learned in my PhD, which was all the extracellular vesicle biology work, and then what I learned in my postdoc, which was the islet beta cell biology and diabetes work, and have now established my own line of research investigating the role of small extracellular vesicles in the pathogenesis of both type 1 and type 2 diabetes. That's a very great question. So as you had mentioned, the development of diabetes, as we know, was quite complex. And we know it consists of environmental and genetic factors that can ultimately contribute to disease onset. So prior evidence has actually shown that the insulin-producing beta cells in the islets of Langerhans, as you mentioned, actually become dysfunctional or they fail, which is now seen as a key hallmark abnormality that leads to eventual failed regulation of glucose homeostasis and leading to hyperglycemia. So as you said, in type 1 diabetes, the loss of this functional beta cell mass is mediated by this autoimmune destruction of nearly all the beta cells, while type 2 diabetes, this is more of a kind of slow progressive loss of functional beta cell mass that's mediated primarily by pro-diabetogenic factors, as we call them, such as low-grade inflammation or even elevations in free fatty acids. So my lab particularly focuses on understanding how these diabetogenic factors impact the ability of the beta cell within the islets to communicate, and thereby disrupting normal glucose homeostasis. So we believe that these extracellular vesicles that are released from these beta cells under these diabetogenic conditions actually become kind of toxic, and as evidenced by alterations in their content and function on neighboring beta cells. So we are interested in studying the content and functions of these altered beta cells derived EVs in hopes of understanding their underlying role in diabetes pathophysiology, which will ultimately help us to develop novel EV-based therapies designed to either restore or actually protect functional beta cell mass. You know, what we know in type 1 diabetes is that inflammatory mediators and innate and adaptive immunity kind of work in concert together to kind of perpetuate this early stage disease onset through eventual loss of functional beta cell mass, as we discussed earlier. So although innate and adaptive immunity kind of play this big role in type 1 diabetes pathogenesis, it's becoming more widely accepted that the beta cells themselves actually may play a more active role in their demise through a compromise of insulin secretory response, meaning through loss of like insulin synthesis and secretion, as well as decreases in beta cell numbers, for example. So our work actually focuses on the role of inflammation in type 1 diabetes that's mediated by specific pro-inflammatory cytokines, which have been shown to recapitulate several aspects of beta cell functional failure in diabetes. So how these pro-inflammatory cytokines affect beta cell function and then eventually lead to failure is unknown. So currently, we're actually funded on understanding the importance of beta cell dialogue or communication under these pro-inflammatory conditions. And so we're actually targeting the extracellular vesicles, as we all know, because they're they're implicated in cell-to-cell communication and studying their role in perpetuating type 1 diabetes pathogenesis through the exchange of these toxic inflammatory cargoes, which we have shown can actually perturb normal beta cell function or insulin secretion. So we are currently looking at the mechanisms in which how these toxic inflammatory beta cell derived EVs induce beta cell dysfunction. And this is important to decipher as it implicates extracellular vesicles as potential therapeutic targets through modulation of their content and also their function in type 1 diabetes pathogenesis. And then lastly, in addition, we're actually recently funded to study a potential early biomarker of type 1 diabetes, in which the data from this work actually came from the mechanistic studies that we had previously done. And as beta cell dysfunction is an early indication of the decline in overall beta cell health and diabetes, we're interested in deciphering early prognostic indicators that would signal the start of the decline of the beta cell using plasma-derived extracellular vesicles from patients, and then profiling them at varying stages of disease progression. Is a little bit newer, but as we previously mentioned, we're interested in studying how these diabetogenic factors can impact communication between the beta cells through exchange of these altered or toxic extracellular vesicles. So in type 2 diabetes, chronically elevated circulating free fatty acids, or what we call lipotoxicity, has been shown to contribute to beta cell dysfunction and thus to the onset of obesity-driven type 2 diabetes. So this prolonged exposure to free fatty acids has been associated with impairments in insulin secretion, alterations in beta cell transcriptional identity, and then as well as apoptosis. But the mechanisms have yet to be fully elucidated. And so we have shown that beta cell derived EVs that are exposed to these lipotoxic conditions actually induce beta cell dysfunction. However, unlike the exposures that we did with the pro-inflammatory cytokines in the type 1 diabetes project, exposures to free fatty acids actually show enrichment of different proteins and even different lipid species on these extracellular vesicles, as well as key differences in the islet transcriptional landscape upon exposure to lipotoxic EVs. So we are currently in the process of solidifying a mechanism for this story, and we'll hopefully be publishing this work very soon. 5 years, what I anticipate is definitely to expand my lab. So it's definitely growing, and it's great. Mentoring for me is a very important aspect of doing research, and so I really look forward to starting new projects with fresh new ideas that are coming from these mentees. I also plan to expand my work and look forward to fostering current and new collaborations at Mayo, and then also across the world. And then, of course, as an early stage investigator, one of the biggest things that we have to look forward to is writing our R01 for our research. And so that's what's probably going to be coming up in the next few years for me. So yeah, I have so much advice, but I'll try to make it concise. So for me, one of the biggest things is early on in your career is to be inquisitive and ask questions. So when you're first starting your scientific journey, this can actually lead you to finding out where you're truly passionate about in your career, and helping to also establish yourself in a niche, which is, I think, very important for us. Also set up long-term and short-term goals. So make a plan for how you want to achieve that goal, with the expectation that it may not go as planned. And that's okay. So if it doesn't go as planned, you can just revamp your plan and keep moving forward. Um, Also, I think what was important for me, and I learned later on in my career, is seeking guidance and help is very important. Go to mentors, your professors, senior members in the lab, committee members, and really establish a network of people that you know will advocate for you early on in your career. And kind of what ties into that as well is network. I think that's very, very important to network. So take any opportunity to promote yourself in your work, give talks, go to, posters, network at conferences, and even promoting yourself on social media now. That's kind of the big thing. So, and then just lastly, as kind of a motto I go by is it's a quote. It's do what you love and love what you do. So basically, you come to work. If you love what you do, it won't feel like work. It'll feel like fun. Even though you go through a lot of hard times, it still will be fun at the end of the day.